In this video, we're going to look at solving trig equations and expanding a little bit on our past videos. So looking at this first example, we're going to solve sine of 2x equals negative square root of 3 over 2. Now there's two parts of this. The first part is we're going to find all possible solutions. And then the second part is over the specific interval 0 to 2 pi. If you visualize your sine function, so just sine of x, it's that periodic function that continues from negative infinity to positive infinity. It's defined for all values of x. And so if you're looking for where a particular, where your sine function equals a particular value, you're going to have infinitely many. So let me illustrate that just briefly. Again, our sine graph has that nice periodic wave that will continue on and on forever and ever in both directions. If I were to draw a horizontal line just below the x-axis, I can see all of these different points where the graph of sine of x and that horizontal line intersect. And obviously, I'm only looking at a small section of my graph of sine of x. So there's even more of these points of intersection, meaning more and more solutions. So depending on how you look at these problems and depending on how it's presented, sometimes it's presented where we find the solutions over 0 to 2 pi first and then find all the solutions. I personally like to look at finding the equations that represent all of the solutions first and then using those to find the solutions in my interval. So that's the way that I'm going to present it, but it's not necessarily that you have to do one before the other. I just think that finding all solutions does help us then narrow it down to the solutions in a particular interval. So we want to solve the equation sine of 2x equals negative square root of 3 over 2. I'm going to use some substitution here. So I'm going to let theta equal 2x. So I'm really solving the equation sine of theta equals negative square root of 3 over 2. Now, if I think about my unit circle, sine is my y value, so it's going to be negative in the third and fourth quadrants. And square root of 3 over 2 is that larger value compared to 1/2. So I'm going to have my two triangles set up where the vertical leg is longer than the horizontal leg. That puts me at 4 pi over 3 and 5 pi over 3. So now I have found that theta is equal to 4 pi over 3 and theta is equal to 5 pi over 3. Because the period of sine is 2 pi, if I add multiples of 2 pi, I will get all of my original or all of the possible solutions because I'm just going to basically keep going around in circles. The reason I'm adding multiples of 2 pi, and k is any integer, the reason I'm adding multiples of 2 pi is because that's the period of sine. But if I look back to my original equation, I'm not solving sine of theta equals negative square root of 3 over 2. I'm solving sine of 2x. So now I want to back substitute that 2x in for my theta. So 2x is equal to 4 pi over 3 plus 2 pi k. And if I divide everything by 2, I'm going to get all of my possible solutions for x. So x is 4 pi over 6 plus pi k. That was from that first solution. I'm going to do the same thing. 2x equals 5 pi over 3 plus 2 pi k. If I divide both sides by 2, x is equal to 5 pi over 6 plus pi k. And these two equations will give me all of the possible solutions for this equation. Now, what I want to do is start finding the individual solutions in that interval from 0 to 2 pi. So really what I'm going to do is take my equations and just replace that value of k for any integer. So I'm going to use that first equation, x equals 4 pi over 6 plus pi k. And I'm going to start changing out the value of k. So I've got 4 pi over 6 plus pi times -1. So I'm going to start with -1 for k, because k can be any integer. So we want to make sure we look at some negatives as well. 4 pi over 6 minus pi becomes -2 pi over 6. And while I can simplify this, I don't really need to because this is outside of my interval, so it's not going to be included. So now I'm going to do 4 pi over 6 plus pi times 0. So now, again, you can see I'm just changing that value of k. This is 4 pi over 6, which is 2 pi over 3. And that's in my interval, so that's my first solution. 4 pi over 6 plus pi times 1 gives me 10 pi over 6, or 5 pi over 3, which is still in the interval from 0 to 2 pi, so there's a solution. If I add 2 pi to 4 pi over 6, we're going to be outside of that interval. So it's not going to be included. So from that first equation, we ended up with two solutions, 2 pi over 3 and 5 pi over 3. Now we're going to look at the next equation. We had 5 pi over 6 plus pi. I'm going to start again with -1. This is negative pi over 6 outside of my interval. Don't need to include it. Five pi over 6 plus pi times 0. That gives me 5 pi over 6, which is inside of my interval, so there's a solution. Five pi over 6 plus pi is 11 pi over 6. Still inside that interval from 0 to 2 pi. And then there's really no need to go to the next value of k, because that would be adding 2 pi, which if I add anything to 2 pi, it's going to be outside of that interval from 0 to 2 pi. All right, next we're going to solve 3 tangent 3x equals the square root of 3. So I'm going to start isolating that tangent 3x, so I can find that tangent of 3x is equal to the square root of 3 over 3. Now this expression, we do want to have some familiarity with it. This is equivalent to 1 over the square root of 3. And if we're trying to work backwards to where this lies on the unit circle, my sine would be 1/2. My cosine would be square root of 3 over 2. And that would give me this expression of 1 over the square root of 3 or square root of 3 over 3. So we're going to let theta equal 3x. So we're trying to find where is tangent of theta equal to this square root of 3 over 3, which looking above, we know that that's where sine is 1/2 and cosine is square root of 3 over 2. So I'm going to try to figure out where theta lies for this equation to be true. So this has got to be in the first and the third quadrant. That's where tangent's positive. Sine is 1/2, cosine is square root of 3/2. So that means we're going to have those flatter triangles closer to the x-axis, which tells me that theta is equal to pi/6 and 7 pi/6. Now we're going to back substitute because we let theta represent 3x. So we have 3x is equal to pi/6 plus pi k. Now here in this example, we're adding integer values of pi because the period of tangent is pi. So you want to be really careful paying attention to the period of that trigonometric function involved in the equation. Solving for x, we get x equals pi/18 plus pi/3 times k. So here's our first equation. Then if I said 3x equal to 7 pi/6 plus pi k, x is equal to 7 pi/18 plus pi/3 k. So those equations will give me all of the possible solutions for this equation. Now we need to find the solutions that are in the interval from 0 to 2 pi. I'm going to start with that first equation. So pi/18 plus pi/3 times -1. So this simplifies to pi/18 minus pi/3, which actually gives me -5 pi/18, which is out of my interval, so we're not going to include it. Pi/18 plus pi/3 times 0. Pi/3 times 0 is 0, so we have pi/18. That's inside my interval, so there's my first solution. Pi/18 plus pi/3. This is 7 pi/18, which is inside of my interval. And a quick comment here, I'm combining these fractions very quickly. I've done the problems in advance, but two, we have technology to help us combine those fractions. To combine pi/18 plus pi/3, you're really just adding 1/18 plus 1/3, and we can use Desmos to do that and have it simplify for us. We can kind of ignore that factor of pi since both of them have a factor of pi and just make sure that's included in our final answer. What I do want to notice is that this 7 pi/18 that we just got in this last solution matches the first term in that second equation. So what that tells me is that if I keep adding multiples of pi/3, now I'm just starting into that second equation. So I won't have to work through finding possible solutions from both of these equations because if I start working with that second equation once I'm done with the first one, the second equation, the very first solution is going to be 7 pi/18, and then we're adding multiples of pi/3, which is what we're already doing with this first equation. So because of that solution being the first value in that second equation for all the solutions, we're not going to actually have to work with both of those. And we're going to see that happen a lot more frequently with equations involving tangent, but we do want to make sure that we verify and we don't just assume that we won't have to use both of those equations. All right, so we're still working with that first equation because we know now that we won't need to work with the second equation, but we need to keep increasing our value of k. So we've got pi/18 plus pi over 3 times 2, or 2 pi over 3. This gives me 13 pi over 18, still in the interval from 0 to 2 pi. Pi over 18 plus pi over 3 times 3. This is just pi, so pi over 18 plus pi. This is 19 pi over 18. Still inside the interval from 0 to 2 pi. Increasing k to 4. Pi over 18 plus 4 pi over 3 is 25 pi over 18. Still in the interval of 0 to 2 pi. And the way that I can quickly tell that it's still in that interval, since the denominator is 18, for it to simplify to 2 pi, it needs to be 36 pi over 18. That simplifies to 2 pi. So anything beyond 36 pi over 18 is now going to be outside of that interval. So we're going to keep going until we get to that, get to a value that's more than 36 pi over 18. Pi over 18 plus pi over 3 times 5. This is 31 pi over 18. So still inside the interval. And then the next one, pi over 18 plus pi over 3 times 6. This pi over 3 times 6, there's our 2 pi. So if we add a pi over 18 to 2 pi, it's going to be outside of that interval. So we have no additional solutions added there. Solve cosine 2x equals cosine of x over the interval 0 to 2 pi. So we're not looking at finding all the solutions, just the solutions in the interval from 0 to 2 pi. Cosine of 2x and cosine of x, those have different arguments. We really want those trig functions to have the same argument, so we're going to use a trigonometric identity, specifically that double angle formula for cosine. So cosine of 2x can be rewritten as 2 cosine squared x minus 1 equals cosine x. We're going to subtract cosine x from both sides because I'm already starting to recognize that quadratic form. So 2 cosine squared x minus cosine x minus 1 equals 0. I'm going to use u substitution here. I'm going to let u be cosine of x. So this is 2u squared minus u minus 1 equals 0. And this quadratic, I'm going to try to factor. The first terms in my binomials need to be factors of 2u squared. So 2u and u are my only possibilities. The last two terms in my binomials need to be factors of 1. So they have to be 1 and 1. Now we want the middle term, the middle two terms, so outer and inner and FOIL, we want those to combine to give me negative u. And we also want to keep in mind that the last term in the quadratic is negative 1, so they're going to have different signs. So if we want them to combine to give me negative 1u, I want negative 2u, so my outer term is going to be negative 2u, and my inner term is going to be positive 1u, and that's going to give me that negative u term in the middle, and negative 1 as my constant. Zero product property, we're going to set each of these factors equal to 0. Two u equals negative 1, u is equal to negative 1/2. Back substituting, u was cosine of x equals negative 1/2. And then solving the next one, u is equal to 1, so cosine of x is equal to 1. So now I've got some pretty basic equations I can use to solve on the interval from 0 to 2 pi. I'm going to start with the easy one. Cosine of x equals 1 when x is equal to 0. So there's our first solution. And then cosine of x equals -1/2. Thinking about where cosine is negative in the second and the third quadrants. And x is going to be, or that horizontal length of my right triangle is going to be the shorter one. So that's going to put me at 2 pi over 3 and also 4 pi over 3. So there are 3 solutions in the interval from 0 to 2 pi. Okay. One last example. 3 cosecant squared x over 2 equals 2 secant x, round values to the nearest hundredth. Find all radian solutions. Sorry, let me read all the directions. Find all radian solutions, round values to the nearest hundredth. So we're going to be doing a lot of work by hand, but we're also going to have to use the calculator if they're asking us to approximate values. I do want to point out that they want radian solutions, so make sure whatever calculator you're using is in the correct mode. I'm going to start by rewriting 3 cosecant squared x over 2 in terms of sine. So this becomes 3. Cosecant is the reciprocal of sine, so this is 3 over sine squared x over 2. And then the 2 secant x, I'm going to write this in terms of cosine, so this is 2 over cosine of x. And when you have 2 rational expressions set equal to each other, we can use cross multiplication to get rid of the fractions. So this gives me 3 cosine of x equals 2 sine squared x over 2. I'm going to rewrite sine squared x over 2 to be sine of x over 2 squared. Let me use some brackets here. The reason I rewrote that expression is just so that I can make that substitution a little bit easier. That square right off of that trig function name sometimes makes it a little bit harder to see that. So we really just have sine of x over 2, which we're going to use our half angle formulas to substitute in something else, and that quantity is squared. So 3 cosine of x, my left-hand side hasn't changed at all, 2 times sine of x over 2 is plus or minus the square root of 1 minus cosine of x over 2 being squared. Now, regardless of whether this is positive or negative, when we square it, it's going to become positive. And we're also going to undo that radical. So this whole right-hand side of our equation is going to clean up really nicely here. So we have 3 cosine of x is equal to 2 times 1 minus cosine of x over 2. Our factors of 2 simplify to 1. So we have 3 cosine x equals 1 minus cosine of x. Start combining like terms. We're going to add cosine x to both sides, giving us 4 cosine of x equals 1. Dividing both sides by 4, cosine of x equals 1/4. So now to solve for x, we're going to use inverse cosine of 1/4. Again, double check your calculator, make sure that it is in radians so that you get the right output here. We're going to get 1.32. Now, recalling the fact that our inverse trig functions are only going to give us an output within a specific range, cosine being from 0 to pi. So 1.32, somewhere up here, 1.32 radians, pi over 2 which is our positive y-axis is about 1.57 radians if we were to look at that decimal. So 1.32 does put us in the first quadrant, which is good because cosine is positive in the first and also the fourth quadrant. So we're going to reflect that terminal side about the x-axis. Our first angle is 1.32. Our second angle is going to be 2 pi minus 1.32. So the second angle, starting from the positive x-axis to that new terminal side, is 2 pi minus 1.32, which is about 4.96. So our values of x are 1.32 plus 2 pi k, and x is equal to 4.96 plus 2 pi k. And those are all of the solutions for that particular equation.